Rank the following compounds in order from least reactive to most reactive. So what we see here are 3 different carbonyl containing compounds. And so when we're looking at a carbonyl, or if we're looking at how it reacts, we want to recognize that you have a partial positive charge on the carbon and a partial negative charge on the oxygen. So when we're comparing carbonyl containing compounds, really what we're going to see always is that you're going to have a nucleophile attacking that carbon. So we are ranking their reactivity as electrophiles. Okay, so when we're comparing our different carbonyl containing compounds, we are looking at electronics, at how much of a partial positive charge we have. Because you're going to have a nucleophile is going to be more reactive towards something with a greater concentration of positive charge. So that's one thing we need to consider. And then another thing we also consider is sterics, right? So if a nucleophile is attacking an electrophile, if it's blocked by having bulky groups around, that could make a difference as well. And so what we have here are 3 different functional groups. And so we need to know how all of our carboxylic acid derivatives and aldehydes and ketones, so all of our carbonyl containing compounds kind of line up in terms of reactivity. And so the most reactive are acid chlorides that we will see. And so these are our most reactive, and there's 2 reasons for that. In terms of carboxylic acid derivatives, that chloride ion is a good leaving group. It's readily replaced. And also, being a larger atom than carbon, it doesn't very effectively donate its lone pairs of electrons, so it's not going to quench any of that partial positive charge. So it's going to be more electrophilic. And so that is more reactive than an acid anhydride. So an anhydride is your other really reactive carboxylic acid derivative, because it's got another good leaving group on there. And so it's not as reactive because this oxygen can donate electron density, but it is shared between the 2 carbonyls, so it's not donating just to one or the other. And then we need to know how aldehydes and ketones kind of fit in. So slightly less reactive than these anhydrides are aldehydes. And so this goes back to the sterics and the electronics. So you've got a carbon group that's weakly electron donating. That hydrogen doesn't donate, and being really small, it's also not very sterically hindered. So that's why we have aldehydes here. And then next is ketones. All right. And again, it's a steric and electronic effect. So you do have 2 slightly donating alkyl groups, so that'll make it less electrophilic than the hydrogen, and it's also more sterically hindered. And then after this, we see our carboxylic acid derivatives that we said in the last chapter are not very reactive. So esters and carboxylic acids are approximately the same, right? So you've got more electron donation from these oxygens, so it's going to make that less reactive, and these are also pretty terrible leaving groups. Okay, but they are slightly better than amides, which are even less reactive. So less reactive than that even is an amide. So your nitrogen might have R groups, might have hydrogen groups. It's still not going to be very reactive because this nitrogen actually donates a fair amount of electron density. Okay, and so we've got this trend from our most reactive to our least reactive. And we can actually say even less reactive than an amide, if we really want to be complete, is the carboxylate anion. So if you deprotonate this, well, now it can really donate electrons, and it's definitely not going to leave. So this would be your least reactive. Okay, so as long as you know that trend and you can pick out your functional groups, right, then we would be able to see that our acid chloride, number 3, right, so following our trend, is going to be more reactive than our aldehyde. And we were supposed to go from least reactive to most reactive. So that's our most reactive. So let me just label these out of these ones, and our least reactive is that ester number 2, which means that our aldehyde is in the middle. Okay, so least reactive to most reactive. So that means I want to put the least reactive first, and I'm going to say, okay, well, that is less reactive than the middle compound, which is the aldehyde, and that is less reactive than that really reactive acid chloride. Okay, so we want to make sure we're reading this and putting it in the right direction. And so that looks like option A.